Hello guys, my name is Valkrishna Srivastava and welcome to CodeWithBK. So in this video, we write a C++ program to find the smallest and largest values in an array. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 3 or 5 are subscribed. More than 95% of my audience is not subscribed and a subscription is very important. So please do subscribe to my channel. So let's begin. So we have to write a C++ program to find the smallest and largest value in an array. Okay. So if I look at the first example, if this is my array, my largest value is 27 and my smallest is 1. Okay, so I'm taking an example of integer array in this case. The idea remains the same for array of any other types. Okay. Example 2 is we have 100 as the largest and 2 as the smallest. That's what we have. Okay, so I'm going to show you how to find the largest in an array first, and then on the very same similar idea, we see how to find the smallest as well. Okay, so given an array, okay, so how do I find the largest? Okay, largest first, okay, and then we move on to the smallest. Okay, so let's for a moment leave aside coding and I'll give you these numbers 8, 49. And I tell you to find the largest, you say right away 100 is the largest. Okay, so let me just break this step a little more further. So what you did was exactly, you said, okay, my first value is 8 and my largest with this only value is 8 because I've only seen my first value. Then you say, okay, I have 10 as my next value and my largest is 8 so far. So 10 is my largest now because 10 is greater than 8. Okay, then you check the third value, which is 3. Okay, 3 is less than 10, so your largest remains 10. Then you check at the fourth value, 2. 2 is again less than 10, so your largest remains 10. Then you see 100. 100 is greater than 10, so now your largest becomes 100. Then you see 49, you have 49. 49 is less than your largest, which is 100, so largest is 100, and that's what you find out. Okay, so we can think of finding the largest in terms of largest so far that we have seen from left to right. Okay, so if I consider my array here, it has indices 0, 1, 2, 3, 4, 5. Okay, so my largest, which is actually largest so far, okay, with index 0 it is 8, with index 0 and 1 it is 10, with index 0, 1, 2 it is still 10, with index 0, 1, 2, 3 it is still 10, with index 0, 1, 2, 3, 4 it now becomes 100, with index 0, 1, 2, 3, 4, 5 it stays 100. Okay, and this is what we do in our code. I start my largest. Okay, I say initialize to 0. Okay, I will iterate my array from left to right, so I will take values indices 0, 1, 2, 3, 4, 5. Okay, if for any index I, ARI is greater than largest, okay, that I have found a value which is larger than largest so far, okay, then I set largest to ARR of I. Okay, so if I go back to my code, okay, I write a function int find largest. Okay, takes an array, okay, and it also takes the length of the array. Okay, as I said, I start with int largest equal to 0. I iterate the array from left to right, all indices. Okay, and at any point if I find a location in the array where the value is greater than the largest so far, I update the largest. So if ARR of I is greater than largest, okay, my largest becomes ARR of I, and that's the value I return. Okay, so let me just run this and check. So I have my int ARR equal to, take the same example, 8, 10, 3, 2, 8, 10, 3, 2, 149. I should get the largest as 100. Okay, so I'll say cout largest is, okay, I find largest. I say int n, the number of values are 1, 2, 3, 4, 5, 6. You can find n as well as size of ARR by size of int, because the type is int. You can say find largest in ARR with this size. Okay, compile and run, compile and run. Okay, largest is 100. Okay, if I add a few more values, say 189, 38, 23. Okay, 189 is the largest so far, so I should get 189. Okay, if I add a couple of more, 789, 0, 789 is the largest now. Okay, all right, I'll take one more example. Okay, I'll say instead of this, I have my ARR as minus 9, minus 2, minus 3, minus 4, minus 11, all negative values. Okay, so in negative values my largest is going to be the closest to 0, which is going to be minus 2. Okay, so when I compile and run this, okay, my largest comes out to be 0, which is none of these values. Okay, and why is this happening? Because if I take this array now as indices 0, 1, 2, 3, 4, okay, I takes indices 0, 1, 2, 3, 4, and I start with my largest as 0. Okay, my largest is initialized to 0, right? So the first value I takes is here, which is 0. My condition is if ARI greater than largest, largest is equal to ARRI. So if ARRI is, I'll take this value and I'll say ARR of I greater than largest. Okay, ARR of I is minus 9. Minus 9 greater than 0, this is false. Okay, so this is false, so this condition is not true, so you move on to the next iteration. So I now comes here, which is I is equal to 1. My largest is still 0, largest did not change. I have my ARR of I as minus 2. Now minus 2 is greater than 0, false. Okay, this condition is false again. So we move on to the next iteration. I was here, comes here now. I equal to 2, largest is still 0, AR of I is minus 3. You do the same thing, ARI greater than largest, minus 3 is greater than 0 is false again. Alright, 0 is greater than minus 3. This condition is false again. You move on to the next iteration. I moves to this location, I is 3, largest is 0, AR of I is minus 4. Minus 4 greater than 0 is again false. 0 is greater in this case. So again nothing happens. You move on to the next iteration. I comes here, I becomes 5, largest is still 0. We have AR of I as minus 11. Okay, minus 11 greater than 0 is still false. Right, again nothing happens. You come to the next value of 5, which is 6, and then the loop closes because I is less than n was the stopping condition. I less than n equal to 5. Okay, is the stopping condition. We reach to 6. So the largest comes out to be 0 in this case because this condition ARRI greater than largest was never true. That's why we should not just randomly initialize largest to any value. Alright, largest should be initialized to any one of these values in the array, any one of these values. Alright, so largest should be initialized to any one value in the set, or which in the array, or whichever set of values you're trying to find the largest. You set ARR of 0. Okay, and that's why typically we pick the first element as the current largest so far, and that's why I explained you the concept of largest so far. Okay, that is when I have my first value, my largest so far is the first value, right? Now for example, if I choose this array, right, I take the same set of indices, largest is now my first value in the array, which is 210. I starts with 0. Okay, we pick up AR of I and AR of I greater than largest. Okay, so when I is 0, okay, AR of I is 210. 210 is greater than 210 is false. Largest remains 210. You move on to the next index, which is 1. Okay, largest is 210. ARR of I is 100. 100 greater than 210 is false. Largest is still 210. Then we move on to the next iteration. I is 2. Largest is 210. ARR of I is 59. 59 greater than 210 is false. Largest is still 210. Then you move on to the next iteration, 3. Okay, ARR of I is 3. Largest is 210. 3 greater than 210 is still false. So largest is still 210. You move on to the next index, which is 4. Alright, AR of I is 87. Largest is 210. 87 greater than 210 is false. So your largest is 210 still. And in the next iteration, you come out of the for loop. So your largest is 210. So even if this condition was always false, okay, we were able to get the largest because we choose the first value, which in this case was largest. Okay, so if we did not pick the largest value, this would be at least true once. Okay, the idea of telling all this is you should be picking one of those values from the set in which you are trying to find the largest. Okay, so that your comparison starts from one of the values in the set and not from any random value. All right, so now, okay, when I run, okay, I get my largest as minus 2. Okay, if I take this very same example, 210, 100, 87. Okay, So I compile and run, I should get 210. Okay, and that is how you find the largest. Okay, the only thing to note here is you should initialize largest not to 0 or any other value, but to one of the values from the set of values from which you are trying to find the largest. Okay, and I'm saying this because in this case you have all the n values available together. Okay, at times it happens you get every value, you generate every value in some iteration after some function call, after some process. So the moment you get the first value, that should be initialized to your largest. Okay, and then you can keep comparing from the remaining values. Okay, moving on to finding the smallest. All right, the idea remains exactly the same. Okay, if I give you this set, okay, 8, 10, 3, 249. Okay, you say smallest is 2. Again, you think in the same terms. If I pick up 8, my first value, my smallest, in short, is basically smallest so far in the values that I've seen. So I've only seen 8, so my smallest so far is 8. Okay, then I have seen 10, my smallest so far is still 8. Then I have seen 3, come between 3 and 8, 3 is smaller. Okay, then I see 2, between 2 and 3, 2 is smaller. Then I see 100, between 100 and 2, 2 is still smaller. Then I see 49, between 49 and 2, 2 is still smaller. Okay, so the same concept we use to find the smallest so far. Okay, so instead here, okay, we start with smallest equal to ARR of 0. Okay, we don't do the same mistake of assigning it to 0. I'll just show you how. You say if you find any value which is smaller than the smallest, ARR of I is less than smallest. Okay, you update smallest to ARR of I. Okay, same thing. I will just copy this code. Okay, change the name of the function to smallest. Okay, all right, I'll say instead of largest, I set smallest to the first value. Okay, change all variables where I'm using the smallest. Okay, and then I say if my value that I find is smaller than the smallest, then I found a smaller value. Okay, so you say small so many times it loses the meaning. Anyways, okay, so this is how you find the smallest. Okay, you iterate, you start with the first value as the smallest and then you compare it with the others. Okay, and you can also start with 1. Okay, because you have already picked the 0th value, but I'm not going to change it to 1. Okay, just remember, set it the first value, iterate the loop and use this condition. Okay, so I can say smallest is find smallest. Okay, this is going to be minus negative value, so minus 87. So clear, compile, run. Okay, commenting this out, uncommenting this. Okay, compile, compiled again, run. Largest is this, smallest is this. Okay, right, then again running this. Okay, largest and smallest. Okay, largest is 789, smallest 0. Let's remove 0. Okay, largest is 789, smallest is 2. Okay, so if we do the same mistake of setting, okay, smallest to 0 just as we did setting largest to 0, here if I do smallest equal to 0, okay, not one of the value and not setting it to one of the values from the set, you see I'll get a wrong answer. So clear, compile, run. My smallest comes out to be 0 and largest comes out to be 789, even though I don't have zeros, any 0 here in this. Okay, because this condition is never true. You start smallest equal to 0, there is no value that will fulfill this condition. Okay, 8 less than 0 is false, 10 less than 0 is false, 3, 200, 49, 189, 38, 23. All these values are not less than 0. This condition is never true. So smallest will never change. So smallest starting with 0 stays 0, just as you saw in the case where we set largest to 0 and take this set of negative values. Okay, all right. This condition either has to be true once or you pick out the smallest. Okay, all right. So now if I just remove this and uncomment this, I get the smallest as well. Okay, so this was the C++ program to find the largest and the smallest, and this is something very standard. So if you're trying to code this in some other programming language, all you have to do is pick up the first value and compare it with all the others. Okay, using this condition. Similarly for smallest. Okay, and there may be cases where you're not working with arrays. Okay, but the idea remains the same. If you have a set of values, list of values, or whatever, you have a linked list. All you have to do is pick out one and compare it with all the others. Okay, so this was the solution and this was the program, and I hope this was helpful. You like this video. So if there is any doubt, if there is a part you do not understand, please let me know in the comments. I always try to answer all the comments. And you can always let me know in the comments if there is a question you want to solve or if there's a concept you want to discuss. So please let me know your thoughts about this video. Please like my video, subscribe to my channel, and thank you for watching.